Good afternoon. In this short video, I'm going to present some of the results that we have obtained in an EU-funded project called Baseline. My name is j.Olsen, and I come from University of Copenhagen. And the results I'm going to present specifically deals with egg and egg products. Now, egg comes into the consumer in different shapes and forms, and they're very different from a safety perspective. 3/4 of all the eggs produced in Europe, there's more than 100 billion eggs per year, are offered to the consumer as whole egg. The remaining 1/4 is heat treated in some form and sold either as what you see here, which is liquid egg products. This is how they look when you buy them in stores in Denmark, or they can be sold in larger quantities for use in industry. Among the heat-treated products are also something you could call more regional egg products. The one shown here is something called long egg, which is sold in the northern Europe. Another example could be powdered egg that is sold in the south of Europe. Common to all these egg and egg products are that the main risk to the consumer is the bacterium Salmonella. It causes a foodborne disease called salmonellosis. It's the number 2 zoonosis, foodborne zoonosis in Europe, and around 40% of cases are estimated to be egg-related. Now let's take a look at these different products individually. So first to the whole egg. The main problem from a safety control point of view is that when Salmonella is there, it's very rare. So it's difficult to set up a control program where you can safely assume that you have detected what is there. Baseline has done an investigation in positive flocks, so visited flocks that we knew already had Salmonella infections, collected eggs in these flocks, and then cultured them by a standard microbiology method. And to show you how low numbers are there, we were only able to find positive eggs in 40% of these flocks. And in total, out of 4,200 eggs, we only found 44 positive. Gives a rate of positive eggs of around 1%. Now, if you look at Europe as a whole and not just into seropositive flocks, it's even lower. You can estimate that around 0.1% of eggs are positive. Now, if you imagine you would try to ensure that you are not selling positive eggs, that meant you would have to sample a lot of eggs and to culture them to find the Salmonella. You can do something about this. You can lower the number of eggs by doing what is called pooling. That is, you can take positive eggs like we've done in Baseline project, so they're the ones shown here, and then you can mix them with, can we go back? We cut. I have to redo this. Okay? Can you do something about this? Yes, you can pool eggs into one sample and in that way get a better sensitivity. This is illustrated in this small experiment performed in a Baseline in which we took positive eggs, shown here, and mixed them with known negative eggs, and then afterwards tried to detect the Salmonella bacteria by a culture method, a standard culture method. And this experiment was repeated 15 times, and the result looks like this. So here you have 15 pools at each of these levels, and this shows how many of them were detected as positive. And immediately when you look at the results, something springs to your mind. First of all, you get more positive pools by this method if there are more Salmonella bacteria. And here is shown 1,000 Salmonella bacteria per egg, 110 per egg. So conclusion number one, you have a higher likelihood of detecting the bacteria if there are more bacteria there. Then next, we asked a computer to simulate a sampling scheme where it over and over again constructed these pools, as shown here, and then tried to take out random samples and see how many would get positive. And from this we get the result that to be 95% sure that you're not releasing batches of contaminated eggs, you need to test 16 pools of 10 eggs each. So in total, 160 eggs are tested. This is, of course, not feasible in real life, so you have to start thinking, what else can I do? And there are different ways you can improve your sampling schemes. You can increase the number of samples. This is not what we are talking here. You can increase the frequency of sampling. You can make bigger sample units, but you can also try to look for better analytical methods. And this we've done in the baseline project. Now, traditionally, Salmonella is detected by a standard microbiological method where you grow your sample in some sort of growth medium, and you even do that in first a non-selective and then a selective step that enrich the Salmonella. And then you spread it on different growth media where you can tell the difference between Salmonella and other bacteria. And then over a couple of days, you confirm that what you see on these plates is in fact Salmonella. All in all, that will take you 4 to 5 days. The alternative we have tested is what is called a real-time PCR method. In this method, you do a short enrichment, only 6 to 8 hours. Then you extract the DNA in there, and you perform a PCR method. This allows you to get a result within 1 to 2 days, and as I will show you in a few minutes, with a higher sensitivity than using the traditional method. Perhaps the best way to illustrate this is to repeat the pooling experiment that we have just seen, and which showed us that we needed 16 pools of 10 eggs to be able to be sure not to release Salmonella positive eggs. The same experiment performed with PCR as the detection method would tell us only to use 8 pools of 9 eggs, so in essence reducing the number of eggs needed by half and also speeding up considerably the analysis. Okay, so conclusion from this short part of baseline is that real-time PCR for detection of Salmonella in eggs is a good alternative to the traditional microbiological method because it provides results in a shorter time, it has a high sensitivity and specificity, and part of the shorter time is that you need not confirm your results. You can rely on the answer you get from the PCR method. If you're interested in trying to establish PCR methods in your own quality control program, there's an ISO standard that shows you recommendation for how to do this. And the method that I have just presented is currently being validated in a small study within the baseline project. Now on to the liquid egg products. They are heat-treated egg products. You can buy them as shown here, whole egg, heat-treated. It can be just the yolk treated, or it can be just the white treated. This liquid egg product falls under the EU regulation number 2073, which deals with food safety criteria in general. And the rule says that Salmonella must be absent in 5 samples of 25 gram using the microbiological method for testing. And in reality, this is complied with in most of the products. So it's very, very rare that these products are actually positive for Salmonella. However, comparable results from US says that 0.3% of the products are positive for Salmonella. In Japan, it's 1.7% for pasteurized egg. And also data on outbreaks in Europe show that mistakes can happen. So in 2007, there were reports on outbreaks related to pasteurized egg white and yolk used for chocolate mousse and pasteurized egg white for dessert and salmon mousse. And more recently, in 2012, pasteurized egg white used by bodybuilders for building up muscle caused an outbreak. So you cannot safely assume that Salmonella is not there. With this very low prevalence of Salmonella, however, the insurance must rely on other things than just testing. So what can you do? Salmonella grows very, very well in egg and egg products. This shows growth curves of Salmonella in whole egg and in egg yolk. In normal egg white, these are 3 different types of Salmonella. They cannot grow. They do not die, but they cannot grow. As soon as you heat treat the white, the whole egg, or the yolk, you get growth curves that look like this for all 3 products. So once it's heat treated, it's a very, very good growth product. So it's very essential to avoid Salmonella contamination of your newly treated product. If you have contamination, however, then this will become the most severe problem if your temperature is high. So this curve shows how temperature influences the growth rate of Salmonella in pasteurized egg products. It's from a published work, and it's easy to see that growth rate increases with increasing temperature. So another way of minimizing risks is to keep your product at low temperature after pasteurization and make sure you get it cooled very, very quickly. You can add things to these liquid egg products that will reduce the growth ability of Salmonella. This shows a graph where Salmonella typhimurium is growing in pasteurized salted yolk. It would normally take off like this, but when 10% of salt is added, there will be a reduction of the Salmonella. Now, Baseline has performed a more systematic investigation of how different factors influence the growth ability of Salmonella enteritidis, which is the most common Salmonella associated with egg, in liquid egg products. And I will show you the summary results here. So what you have here is once again an expression of how good they grow with a growth rate, and then different factors that we have investigated whether they influence the growth. And what you see is, as you have already seen in one slide, that with increasing temperature, growth increases very steep. So the higher the temperature, up to a certain limit, the better Salmonella is growing. Salt, on the other hand, has the opposite effect. So the more salt you add, the less Salmonella will be growing. Lysozyme, which is a naturally occurring enzyme, does not have any effect in these investigations, while the effect of pH is a slight decrease with an increasing pH. The same investigation has been made where salt is substituted with sugar, and the trend is the same. a steep increase with temperature, a not so steep decrease with the sugar, but a decrease. Lysozyme, no effect, and pH in that experiment has no effect. So based on this, the recommendation from baseline investigations to try to avoid food safety problems with liquid pasteurized egg products is avoid abuse temperature before pasteurization, because that will increase the number of salmonella in your raw material. Be very, very strict on control of your pasteurization temperatures. And then essentially avoid cross-contamination from raw material and equipment to your newly pasteurized product. And make sure you get your pasteurized product down to a temperature where salmonella is not growing immediately after pasteurization. And then, of course, you can add salt or other preservatives, and that is normally done in Europe, and that will prolong the shelf life of your products. The final thing I will touch upon in this video is some of the tools that have been made in Baseline that can help you to design your own sampling plan for your specific purpose. The situation we deal with here is something called powdered egg, which is a dried, heat-treated egg product. These can be recontaminated with salmonella, and then it's a difficult product to design a sampling scheme for, because salmonella will not be uniformly distributed in your sample or in your batch, but will be small spots of positive things. Baseline has created a tool where you can go and design a sampling scheme where you define the number of samples you want to test, the weight of each sample, given a certain anticipated pre-contamination of your sample, the lot weight of your batch, and how many bacteria you think are there per gram when it's a positive sample. Then it will tell you the likelihood of making a mistake, I call it. So the likelihood of accepting, if you do a microbiological testing, this lot, even though salmonella is present. Now you can sit down and play with this. You can design your own sampling schemes where you vary the number of samples you take, and you can vary the weight that your samples have. You can vary how big a proportion of your batch you think is positive. You can also vary the weight of your batch and how many bacteria are present in the batch. And then you can start looking at trends in this. And no need to go in details here. I will just summarize for you what we find when we repeat this over and over again. First of all, low contamination versus high contamination. So few bacteria per positive spot versus many bacteria or more bacteria per positive spot. Then sampling is more efficient when there's more bacteria, not surprisingly, and this decreases your probability of falsely accepting a lot. When there are more positive spots, so you increase the contaminated part of the lot, then sampling is also more efficient, but not as a linear trend. It's in the lower end, it has the biggest effect. Once you get up to higher proportion, there's no increase in your sampling efficiency. The lot size, on the other hand, does not significantly affect your likelihood of falsely accepting a lot. And then perhaps the most important thing to communicate is that you can look at the ratio between the number of samples and the weight of the samples. And increasing the number over the weight is more effective than doing the opposite, regardless of what contamination you have and what proportion is positive. With this, I hope I have given you a small insight into what we have produced in this part of the baseline project, and you're welcome to look at the baseline website for further information. Thank you.